Igneous rocks have something called a texture, which we refer to most often as the grain size, is the key component of that. And so if you know from your class, the two common things we talk about are phaneritic, which means the grains are large enough to see them. If you were to have the sample, you would say, okay, here's a grain, here's a grain, here's a grain. And then we also have aphanitic, which means the grains, they're not invisible, but you can't see one grain from the next. So oftentimes these rocks just look like they're all one color because the grains kind of blur into one another. And what determines how large these grains grow is actually how slowly the magma or lava cools. All right, so let's take a look and let's think about this. So if we have this either magma or lava, magma's below the surface, lava's at the surface, and let's say that it's going to cool really slowly. So you start with this slow cooling and you have these nucleation points where these minerals start to grow. And as it cools very slowly, each of those nucleation points are a site for that mineral to grow bigger and bigger and bigger until they grow into one another and you see something like this. So this larger grain size happens with slow cooling, because you have time for those grains to form. Now I think you can see that with something like this aphanitic texture, this means that the melt cooled very quickly. So there wasn't a lot of time for this slow grow to happen. So they just kind of instantly froze into place and you get these very, very fine grains. And so the overall idea is that the slower something cools, the larger the grains will be. So then we get into other textures that you may learn in your class called pegmatitic, where the grains get really large because they cooled very slowly. So there's a grain of a mineral called feldspar up near Mount Rushmore that's like the size of a small car because it cooled really, really slowly. Now there's a texture that you might learn in your class called porphyritic. And this just means that there's two distinct grain sizes. So one possible example of this would be that you've got some larger grains and then everything in the background, which we call the ground mass, is going to be finer grained. So remember, the background is called ground mass. These larger grains are called phenocrysts. And so we'd actually say that our phenocrysts are kind of phaneritic, our ground mass is aphanitic. And so how did this happen? Well, the way that it happened is that you started slow cooling. So you started like this, and these minerals started to grow. And then something happened, so probably that magma rose to the surface and cooled very quickly. So you got this aphanitic texture. So you started slow, and then you went really quick, and so we would call this porphyritic with a aphanitic ground mass because the background cooled very quickly. Now, one other thing to think about is that you can have another type of porphyritic rock where you've got really large crystals as your phenocrysts, and then you've got just regular large crystals as your ground mass. So in that case, it would have cooled really, really slow. You built these really large crystals, and then maybe that magma moved up a little bit, so it cooled a bit faster, and then still created large crystals, just not as large as that first round. And in that case, you would call it porphyritic with a phaneritic ground mass.